Hi, we are discussing about inverted search project in data structure. Using this an inverted search. Inverted search is the searching of a large volume of text-based data. Text-based means it's words or it's numbers. And here we can it is storing mappings from contents to its location. That means it storing the contents, the words or the numbers, and it is located in the like a table or it's stored in the documents. Why we are using inverted search? It's because it is very fast and efficient text searches. We can search anybody easily. We can find out a word from different files. While we create a database, and if we add those documents into that database, we create that database, and so after that, if we search any word from these much documents or files, we can easily find out the word. Then an inverted search is in two types. And indexing. Here we are using inverted indexing. This indexing is basically in two types: inverted indexing and forward indexing. You can look the difference between those two. Inverted indexing means uh, it stores mappings from words to documents. First, it make an indexes of words. First, it create like that, and it will show the path to the documents. Shows the documents contains those words like that. So first, it will scan the documents, all documents, and list out the unique words from the documents, and it will list like that. An example for an inverted indexing is index at the back of the books. And forward indexing, it's somewhat different from reverse indexing. So inverted indexing, it is doing it will scan the document, each document. First it will scan the document and list the words, and like that it will scan each document one by one. And first it uh, scan a document, and then it create a list of words, unique words from that document only, and it will go to the next. So it will take some time while comparing inverted index. An example for the forward indexing is table of contents. At the beginning of a book, it will show the table, uh, which of the topics are there, like that. Why we are using an inverted indexing rather than forward indexing? The inverted indexing is easy to develop, and it is used in document retrieval systems. So it is a fast process, so we can easily find out the words or documents. If there is so many documents, we can find it very fast. And it is used in search engines like Google, Yahoo, like search engines, because while we are searching anything, if we start with some two or three letters, that time itself it will show some related things. So it is easy to search. No need to type all the words or all the sentence. Yeah, here inverter search is better than forward. Inverter indexing is better than forward indexing. It's because for inverter indexing less time is needed, and for inverter search is based on words. It is created some indexes of each words, but forward bias means it is based on documents. First document, it will take first document as first index, 0th index, and it will point to the each words which is listed, unique words which is listed in that document, and then it will go to the to start check the second document like that. So it takes some time. We are using the inverted search and search engines, and database systems, and in social media platforms. Mainly, there are 5 operations we are doing in this project. This inverted index method. First one is create a database. Initially, we want to create a database to store the words, to to create the indexes with the words, and to uh, get the path of where the which of the so which of the files contains these words. So we need to create a database. The database will contain the first it will contain the words, and it will contain which files contain these words, how many times these words are present, how many uh, files contains this word. So it will show you unique words, and it will show which of the files contains the mm, this word. So it does to want to see the table. We need to first we want to create a database, and if we are using the second operation, we are using the second operation, display database. It is to show the table which words are present, and how many times that word is present, and which file contains that word. That like things will show in uh, display database. It will display the entire database what we created, and it will show the full list of that database. Next one is search database. If you want to search a word, is it contain this file or not? Just search that word, and it will show in which file contains this word, and how many times it is present, which of the files contain this word. And update database. Update database means if while we adding a new document, or also while removing any document, while adding a document, we need to add that file, and we need to add the add the words, number of words, file counts, etc. And while removing, we need to reduce these things. That means if we modify anything, any files from this list, we need to change it in that database. So we are using the operation update database. Then the last operation is save database. It's used to reduce the time required for search process. That means if we save a database, it will be easy to, it will reduce the time for searching. If you want to search a word that time, it will not take as much time when we search without saving. So if we have a lot of files after save, and we do the search, it will be less, it will take less time. And also if any system failure will happen, if we saved that file, it will be there, we didn't lose. The main challenge of this index inverted search is more memory is required. It's because if so many words are in each file, and if it is a new unique word is present there, it need to create a new index. So for each unique words, we want to create each index. So it's a lot of memory is required for this. We go to the demo part. can here I have created 2 3 files. First file contains hello, how are you. This much words are contained in this file1.txt. File2.txt contains how are you, hi, why. This is file3.txt. So we are adding, first we are using file1.txt. So file1.txt is add as the 0th index in the linked list. So we created linked list here with the file1.txt as a node, 0th node. So enter the option. First we want to create the database. So a database is created successfully. Now we can display the database which is created here. This is the database created. These are the words contained in the file1.txt. And here syntax is based on the alphabets. The first letter of these words, here for 0, and if it is Z, it will be 25. And the words, the file count, and which file is that, and how many times it showing. We can search any word. You can search one. Word one is present in one file. The file name is file1.txt, and it's showing one time, only one time it's showing. And now we can do save. We can create a file here. Already a file is created here, new file. Now the database is saved successfully. Database is saved here. The words and file name, counts, etc. All things are saved here. You can check with the 2 files. The first file2.txt is as node 0th node, and file3.txt is takes us the first node in the linked list. And here we created a database. Here the created database is displayed here. 2 files we are here we are using 2 files. So the word hi is present in 2 files. Those files names are here, and in file2.txt it is showing one time, and in file3.txt it's showing 2 times. You can save this. saved here.